Hello friends, warm greetings and welcome to my YouTube channel. First of all, I thank you for taking your valuable time and interest in this laboratory-based video. In this video, I'll be demonstrating the steps involved in the laboratory analysis and estimation of organic carbon in any soil samples following the old and widely adopted method called Walkley and Black rapid titration method. For your convenience and information, this video revolves around the following. First, we will quickly introduce about the soil organic carbon and then the formula used for its calculation. Then we'll move on to the second stage, which is the preparation of chemical reagents and indicator that are required for the analysis of soil organic carbons. And then the third steps would be standardization of ferrous ammonium sulfates. And then fourth step would be the estimation of soil organic carbon. And lastly, we'll do is the calculation of soil organic carbon using the Microsoft Excel. So to begin with, soil organic carbon is actually one of the very important and vital parameters used for determining the soil productivity and its fertility. Now, a significant amount of organic carbon in any soil is mainly attributed by the presence of natural vegetation's cover integrated with continuous decomposition process of plants litter. And in contrary, depletion of vegetation cover has resulted in presence of less organic carbon in the soil. And the formula used for calculation of our soil organic carbon is as given on the screen. And we will deal more about it last stage, which is the calculation of soil organic carbon using Microsoft Excel. Now we'll move on to the second stage, which is the preparation of chemical reagents and indicators that are required for the analysis of organic carbon content in the soil samples. So the first reagent we are going to prepare is preparation of 1 normal potassium dichromate. To do so, first take out some amount of potassium dichromate into a petri dish. Dry it inside an oven at 105 degrees centigrade for 4 hours. After 4 hours, take out the potassium dichromate from the oven. You see that it's changed in color. And place it inside a desiccator for a few minutes. After some time, take it out. In order to avoid unnecessary disposal of unused chemicals and to save chemical, first of all, check how much samples do you have. And accordingly, you prepare the reagent, because if you prepare too much of reagent, that'd be just a waste, right? So in case if you want to prepare a 250 ml reagent, then you can weigh exactly 12.26 gram of potassium dichromate. And in case if you want to prepare 500 ml of reagent, you can weigh 24.52 gram of potassium dichromate. And in case you want to prepare a 1000 ml reagent, then you can weigh 49.04 gram of potassium dichromate. However, in this video, I'll be weighing only 12.26 gram of potassium dichromate and dilute it in a 250 ml distilled water. Now pour it into a 250 ml and then dilute it with distilled water. Now, this is a 1 normal potassium dichromate solution. After this, the next step will be the preparation of ferrous ammonium sulfate solution. For this, again, depending on how much samples that you have, accordingly you prepare. Okay. So for this demonstration purpose, I'm going to use the least amount of chemicals. So I'm going to weigh 49 grams of ferrous ammonium sulfate or FAS. This is 49 gram of ferrous ammonium sulfate, and then I'll transfer it into a 250 ml flask. After transferring the ferrous ammonium sulfate into a 250 ml volumetric flask, the next step is add 5 ml of sulfuric acid into the 49 grams of ferrous ammonium sulfate. Now, once this is done, then dilute this with distilled water, and always prepare a fresh ferrous ammonium sulfate for any analysis. Now, this is a 0.5 normal ferrous ammonium sulfate. Next, the preparation of the diphenylamine indicator. For this, weigh 0.25 gram or 0.5 gram of diphenylamine and place it in a 100 ml beaker. Then to this, add 10 ml of distilled water. And then measure 50 ml of concentrated sulfuric acid using a measuring cylinder. And now add the 50 ml sulfuric acid to the diphenylamine diluted in 10 ml of distilled water. And always remember to store this mixture in a dark bottle. Be precautioned while pouring a concentrated sulfuric acid. And this is a diphenylamine indicator. Now, once you have prepared diphenylamine indicator, then all the chemical reagents and indicators essential for analysis are ready. And once you have done this, we'll move on to stage 3, that is the standardizations of the prepared ammonium sulfate. For this, first, pipette out 10 ml of potassium dichromate into a 250 ml conical flask. Then to it, add 20 ml of concentrated sulfuric acid, swirl the mixture and let it cool for some time. After cooling, next add 200 ml of distilled water into it. Again, swirl it. And to it, again, add 10 ml of orthophosphoric acid. And last but not the least, add 1 ml of diphenyl indicator into it. And on addition of diphenyl indicator, you will see that the color changes to dark blue. Next, this dark blue solution will be titrated with 0.5 normal ferrous ammonium sulfate till the color changes to green. To do so, first fill the burette with 0.5 normal prepared ferrous ammonium sulfate solution and then titrate the solution till the color changes into blue. And remember to record the initial reading of the burette. After some time, you'll see that the blue color changes into green. So always remember to note down the final reading from the burette. So from this titration, you will be recording the initial and the final reading from the burette. In the same exact manner, repeat the same process for replicate 2 and replicate 3 for standardization of the ferrous ammonium sulfate in order to get 3 replicates. So let the burette readings be as given below. So the burette readings for the first, the one that I showed is from 0 to 10.3, and the one that I did not show in the video is from 10.3 to 20.8, 20.8 to 30.8. So because we always need 3 replicates. Okay, so after that, the volume of our ferrous ammonium sulfate required to titrate the solution is 10.3, 10.5, and 10.1. And if you take the average mean value, it is 10.3. And this 10.3 value will be the mean value data that will be used as a blank reading later in the calculation section. So remember this value, later on we'll use it. Okay. Now we'll move on to the fourth stage, that is the estimation of soil organic carbon. So first of all, weigh 0.5 gram of air-dried soil which has been passed through a 0.2 mm sieve. We'll have 3 replicates, and then to each of the replicate containing a 0.5 gram of soil samples. Add 10 ml of potassium dichromate. After adding, swirl the mixture. Then next, add 20 ml of concentrated sulfuric acid into the 3 different replicates. Then after the addition of sulfuric acid, let the soil sample stand for 30 minutes. Then half an hour later, when the sample is being cooled down, add 200 ml of distilled water into the mixture. Apologies for the written part, it's not 100, it's 200. It's a mistake. Then to it again add 10 ml of orthophosphoric acid. Next, to each add 1 ml of diphenylamine indicator. And you'll see that the color changes to dark blue once the diphenylamine indicator is added. See? See? The color changes to dark blue. Now, for this, titrate the dark blue solution with 0.5 normal ferrous ammonium sulfate solution till they turn green. So always remember to record the initial reading from the burette before you start the titration. Keep adding slowly till the color changes. And after the solution change into green, remember to record the final reading from the bureau. And for demonstration purposes, let the period reading for the soil sample analyzed be as given below. And this reading will be used for organic carbon percentage calculation later. So once you have completed this stage, then the laboratory analysis stage is complete. And after that, we'll move on to the last stage, that is the calculation of soil organic carbon content using Microsoft Excel. Now let's do the calculation for soil organic carbon percentage. And as you have received earlier, the formula is this, where organic carbon percentage is equal to 10 bracket B minus T divided by B into 0.003 into 100 by S, where B is the volume of the ferrous ammonium sulfate required to titrate the blank. And if you remember this, we have done, we got the average mean value, which is 10.3. All right. So which means that the B value, we have obtained the P value. Now the T value, what's T value? T is the volume of the ferrous ammonium sulfate required to titrate the soil samples. For 3 different replicates, we have 3 different values, right? So we'll see that in the calculation soon. And S stands for the weight of the soil. So which is 0.5 gram. Okay. First, step number 3. Remember that we have titrate the ferrous ammonium sulfate. And from there, we get the bureau reading and the final reading and the initial reading. And from here, we'll get how much was the volume of ferrous ammonium sulfate. So what we have to do is just have to take this value, the final reading minus the initial reading. Okay, so we get 10.3 for replicate 1. And for replicate 2 and 3, we just have to drag. And from here, we have to calculate the mean value. So the mean value will be, you have to go to auto sum average, and then you just have to highlight this value here and then press enter key. So the value is 10.3, right? So you just have to write here 10.3, which is the mean value and which is the B value in the formula. Okay, so once we have obtained the B value, which is 10.3, now we move on to the values for titration of the soil samples. So we have for titration of the 3 replicates of the soil samples, this is the initial reading, this is the final reading, and now the volume of the ferrous ammonium sulfate should be the final reading minus the initial reading will give you the volume of ferrous ammonium sulfate. And to this, we will get to do is equal sign final reading minus the initial reading, okay, which is 6.1. And then we'll get for replicate 2 and 3, which is 5.7 and 6. So these are the volume of ferrous ammonium sulfate required to titrate the soil samples. Okay, so this value will be the T value. Just remember, 6.1 will be the T value for R1. T value for R2 will be 5.7. T value for R3 is equal to 6 because T is there in the formula, right? Okay, next, do the calculation for soil organic carbon percentage. Once we have the T value and the B value, see now we have the B value and the T value. S value we already know. So first thing first we'll do is this portion of the formula, B minus T. So what is B? B is the B value is the blank reading. Okay, so which is, how much is it? It's 10.3. So 10.3 will be minus T. Minus T will be the, for replicate 1, will be 6.1. So we get 4.2. So B minus T will be 4.2 for replicate 1, and it will be 4.6 and 4.3 for replicate 2 and 3 respectively. Now next part is we'll do the calculation for this section of the formula. So you just have to equal sign 10 into B minus T for replicate 1 is 4.2. This is the one, right? 4.2 divided by B. What is the B value? This value. So this will be your 10 P minus T divided by B. Similarly, you cannot drag this because it will not be the same. Okay, so here it will be 10 into for R2 for replicate 2, the B value, P minus T value is 4.6. And you divide it by B, which is 10.3. Now you'll get this value here as well. The last equal 10 into, for replicate 3, it'll be 4.3, right? Divided by 10.3. So now you have obtained the value for this part of the formula. So here, just to make it easy, for sake of everyone, we'll make it like this. Okay, so we have to keep it this way for easy calculation. Now, and what is the amount of soil samples that we use? 5 grams or 0.5 gram, right? So it'll be 100 divided by 0.5, right? So it'll be the same for all because we use the same amount of soil samples. So now once we have obtained this, now the easiest part will be just have to use this last stage. So it's equal to this part with 10B minus T divided by B, then you into 0.03, right, into 100 divided by S. This will give you the amount of soil organic carbon for replicate 1 and replicate 2 and replicate 3. See, so we'll just make it values here with the number after decimal. Okay, so now these are the soil organic carbon percentage for replicate 1, replicate 2 and replicate 3, but we are going to use in the average value. So just drag this number here and then average. So your soil organic carbon percentage in the samples that we analyze, average mean value is 2.54. So similarly, in the same manner, if you have 2, 5, 6, 10, whatever the number of some samples, you always have to first find the blank reading by standardizing the ferrous ammonium sulfate solution. And then after that, you have to take a replicate for all the different soil samples. Okay. And from there, you follow this procedure, B minus T, this part of the formula, this and this with the volume of soil. And then finally, you get the soil organic carbon percentage for each replicate, and the one that you'll be expressed in your result is not these, but there is this value, with single value, which is 2.54%. So with this, we have come to an end of this video. The reference for this video is from SK Mighty, the prescribed book for conducting soil analysis. So with that, and I hope all of you will be benefited after watching this video. And I hope you have learned, and I wish and I pray this video will be of great help, especially to students right from the graduate, undergraduate, and maybe some researchers as well. So with that, if you find this video helpful, please kindly share, like, comment, and do subscribe to my channel. So once again, thank you for your love and support. God bless.